Hey everybody, it's Mr. H here. We've made it to chapter 8. This is 8.1 on what's called the law of sines. What that deals with is solving oblique triangles or triangles that do not have a right angle in them. So when you're looking at these pictures, maybe ignore the red dotted line H. We're looking at the triangle ABC. We don't have any right angles, right? A, B, and C are all non-right angles. You could have an acute one where all the angles are less than 90, or you can have an obtuse ABC where you have one angle that's greater than 90, like right here, angle A is greater than 90. And as long as you know at least one side, so one or more sides, and then any two measurements besides that, then you should be able to solve the entire triangle, find all lengths and all angle measures. There are cases that you're going to have to know in solving oblique triangles. So here's all of the cases below. There's 4 of them, and we'll get to these as we do examples. But this one, case 1, is 2 angles and one side, and there's some different orders to that. Or 2 sides and one angle, that's SSA. Or 2 sides and one angle, but the angle is between the 2 sides. So we'll look at the difference there in a minute. Or you just know 3 sides. So those are all the cases in which you can solve a triangle with either law of sines, or we'll get to law of cosines in 8.2. The one thing you cannot solve is an AAA. If you just know 3 angles, that is an infinite number of triangles because it doesn't define the sides. Okay, let's get to the law of sines. So it's a formula, and where you're going to use the law of sines are those first 2 cases. So those things, and we'll get to all the cases in examples. But first, where do these formulas come from? Well, it just comes from regular right triangle trigonometry. If we, let's steal this triangle up here. We'll just bring it down so we can use it to derive the formula. Now, what you have here, if you look at this cut in half with that H, or not half, but if we define that height H, then you divide it into 2 right triangles, and you can use right triangle trigonometry. Like, for example, this triangle here, you can say that the sine of C is opposite, which is the H, over hypotenuse A. This triangle here, we would have sine of A equals opposite H over hypotenuse C. Okay, now the next step to derive the formula is to solve each of those little equations for H. So on the top one, let's multiply both sides by A, and the bottom one, let's multiply both sides by C. Then you end up with, on the top one, you'll have basically H is equal to A sine C. And on the bottom one, you have H equals C sine A. Okay, so that's that one. That's that one. Now, both of them have H equals. So that must mean these 2 things are equal. So I can combine this into just one equation. A sine C should equal C sine A. And then finally, to get one of the branches of this law of sines, let's divide both sides by AC. Okay, then here the A's cancel, and there's the C's are canceling, and we end up with sine C over C equals sine A over A. So there's the law of sines. Now it looks a little upside down, and then there's this one in the middle, right? There's actually 3 of them. But in the end, you could just flip those over. So this is the same as saying C over sine C equals A over sine A. That's also true. And if we wanted to include B, we could start over and draw a height going a different way, like maybe like that, and then involve sine B as a ratio, but there we have it. So it's just a ratio of a side to the sine of the angle. One thing to note, we got lots of A, B's, and C's, and capital A, B's, and C's. So in these triangles, always note that angle A is opposite side A. Angle C is opposite side C. And angle B, this should be labeled B down here, is opposite side B. Capital letters are always angles, lowercase are always sides. So let's do an example. Here we're just given 3 pieces of information. We have 2 angles and a side. So let's draw it out and see what kind of case we have. So it doesn't really matter where you put the angles, but usually we're going to just do it standard ABC, right? So I'm not really drawing this to scale even, but that angle up there is 42. And this angle down here is 61. And then where is A? Well, if this is angle A over here, here's side A over there. And then if that's B up top, this is little b, and that's little c. So we're trying to find big A, little b, little c. Okay. So notice what case we have here. This is angle, side, angle. That's because the side that's known is right between the 2 angles that are known. In an angle side angle case, the first thing to do, or the easiest thing, is to find the 3rd angle. Right? So let's get A first. Angle A, I could just use the 180 rule. It's 180 minus 42 and 61, right? Because I know how all the angles in a triangle, no matter what, is adding up to 180. From geometry, that's 77. All right, so we already have one answer. Angle A is 77, okay? Next, we're going to set up a law of sines. So it doesn't matter what side we find next, B or C. So let's just find B. And so I'm going to start with B over sine B, which is 42 degrees. Okay. So I'm using this ratio right here. And then I can set it equal to either one of those. It doesn't matter which one, just you're never going to set it all 3 at the same time. Just choose one, whatever you're seeing in the picture. So let's see. I don't want to use C because I don't know the side C. So I'm going to use A. So the side is 8.4 and the angle, we just found it, is 77. Now I have an equation with just one unknown and I can solve for that unknown value. Okay. In order to do that, to isolate the B, I'm just going to multiply both sides by the sine of 42. And that cancels there. And we can now calculate that. Now just make sure you're in degree mode in your calculator. And you're just going to type it in just how it looks. You might want to experiment with this with your calculator to make sure you get the same answer as me. So this should end up being 5.768. So approximately, if we're doing 1 decimal place, that's 5.8. And there's B. For C, we're gonna have to set it up and do it over again. So we're gonna now, I would try not to use the values that you've rounded. So try not to reuse that B. So when I go back to my triangle, I'm going to put C over sine C, right, equals, now I have to use that A again, 8.4 over sine 77. Right, so I'm avoiding using the B ratios. Okay, and so on this one, I'm just going to multiply by the sine 61. So it's going to be 8.4 times the sine of 61 divided by the sine of 77 in your calculator. And we should have this triangle solved. So this is going to end up being about 7.5. Now, a quick check is the largest angle should be opposite the largest side. So in this case, that's the A, which is true. It's 8.4 and 77. The medium, which is the 61, should be the medium side, 7.5. And then the smallest angle, B, 42, should be opposite the smallest side, 5.8. So that's a quick little check, that you might catch an error that way. That's always going to be the case. Okay, let's try another one. Here, if I draw this one out, let's see what kind of scenario we have. We've got an angle that's obtuse, so maybe I should draw this as an obtuse triangle to make it kind of accurate. Right? So we're going to go kind of like that. Right? Where here's your angle C, 100.5. Okay, and then little c is 55.4 over there. And then if this is A down here, we have that as 27.3. And then we'll call that B up there. So this is little b, little a, doing the opposite thing. This is the case side, angle, angle, right? Because the side is not between the two angles and is on the outside of the two angles. Okay, so that's a little bit of a different case, but you can still use the law of sines. They're still going to start this the same way. Right. B is going to be 180. Use the 180 rule. That's 5. Okay, so I'm just doing the easiest one first. Right, knock out that angle, and that's 52.2. And then jump to a law of sines. Let's see. The one ratio that I'm given is the C. So let's go and find that A first, right? So we have A over sine 27.3 is going to be 55.4 over the sine 100.5. Okay, so multiply both sides by sine 27.3. And there's my calculation. All right, and let's just calculate that. Again, I would just punch it all in at once into your calculator so you don't have any intermediate rounding errors. You get a most accurate answer possible. So I'm getting 25.8 on that one for A. Okay, one more. Let's see, we got A, now we need B, right? So we're gonna again start off with what we're looking for, B, and that's gonna be over the sine of 52.2. And then let's use the C again, that's the one that was given, 55.4 over sine 100.5. Okay, multiply both sides by sine 52, so we're gonna have 55.4 sine 52.2 divided by sine 100.5. Calculate that out, and we've got a winner, or at least a completed problem. I'm getting 44.5 on that one, rounded to 1 decimal place. Okay, so we got it solved because we found all the sides that were unknown. Okay, that's a good stopping point. We're gonna get to the ambiguous case next. That's where the fun really begins. Hope it's making sense, and let me know if you have any questions. Okay, talk to you later.